Let X represent the number that occurs when a 12-sided red die is tossed, and Y the number when a 12-sided green die is tossed. Find E of X plus Y. Now, when a 12-sided die is tossed, you can get 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, or 12. And each of them would have probability 1 over 12, because there are 12 points. All probabilities are 1 over 12. So this is X, and this is f of X. And so E of X would just be summation of X fx. So it'll be 1 times 1 over 12 plus 2 times 1 over 12 plus all the way up to 12 times 1 over 12. And 1 over 12 can be factored out. So 1 plus 2 plus all the way up to 12. And we know that if you have this kind of arithmetic progression, then you add n by 2, n plus 1. So it'd be 12 numbers. So it's 12 by 2, 12 plus 1. So in general, so let's finish the problem and then I'll mention the general formula. So that is 6, and this is 13. So the result of this is 6. So E of X is 6. E of Y will also be 6 because that's also a 12-sided die. And we have to find E of X plus Y. So that's just E of X plus E of Y. 6 plus 6 equals 12. Okay, what's the mistake here? N by 2, n plus 1. 13. So 1 through 12. N by 2, so 12 by 2, that's a 6, and n plus 1, so that result is 6. Number, okay, let's see what's the mistake here. Oh, suddenly I changed this into a 1 by 13. That was a 1 by 12. So the result is not 6 here. So 6, and this is 13. So 6 1 times, 6 2 times. And so it's 13 by 2, it's going to be 6.5. EY is also 6.5. And will be 6.5 plus 6.5 equals 13. Find E of X minus Y. So that would be E of X minus E of Y. 6.5 minus 6.5, and the result will be 0. Five minus 6.5, that's a 0. And E of xy. So now, if two variables are independent, then E of xy is E of x, E of y. is equal to E of X, E of Y, if X and Y are independent. So in general, that's not the case, but for independent variables, that's the case. And now, why are X and Y independent here? Because X is what shows up on the red die when it's tossed, and Y is what shows up on the green die when it's tossed. And obviously, there is no dependence on the two numbers. Whatever comes up on the green die has nothing to do with what is in the red die, and similarly, whatever is in the red die has nothing to do with the green die. That's why they're independent in this case. So it would be 6.5 times 6.5, and that's 42.25. Okay, so this time it's a six-sided die. And Y is also what happens on the six-sided die, and we have to find the variance of 7x minus y. So let's first find the variance of x and variance of y. So for the six-sided die, we could have 1, 2, 3, 4, 5, and 6. And each number has probability of 1/6 because there are 6 numbers. Each one is equally likely. So E of x then in this case, summation xfx would be 1 times 1/6 plus 2 times 1/6 plus all the way up to 6 times 1/6. So 1/6 can be factored out. 1 plus 2 plus 3 plus 4 plus 5 plus 6. And these can just be summed by brute force, 15, 18, 20, 21. So 21 by 6, and that's 3.5. And E of y will also be the same similar dies. So 3.5. And this time, since we need the variance, so we'll also need the E of x squared. So that would be, so now the x values would be squared. So it'd be 1/6, and just square the x values. So 1 squared plus 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25, and 6 squared is 36. So 61, 77, 90, 91 by 6. So E of x squared is 91 by 6. So let's go to a new document. So E of x came out to be 3.5. E of x squared was 91 by 6. And therefore variance of x equals E of x squared minus EX whole square equals 91 by 6, and 7.5 is 7 by 2. I mean 3.5 is 7 by 2, so that'd be 49 by 4. And this 12 to 182 minus 3, 147. So it's 35 by 12. And that will also be the variance of y, because there is absolute symmetry. Both the die are identical. So variance of 7x minus y would be 7 square variance of x plus -1 square variance of y. So 7 square is 49, and variance of x is 35 by 12. And 1 times 35 by 12. So it's 50 times 35 by 12. and they want a fraction, so that's 1750 by 12, so that's 875 by 6. So this one is 875 by 6. Okay, now we want variance of x plus 5y minus 3. So, okay, now remember that the formula that we used was that variance of ax plus by plus c, that's equal to a square variance x plus b square variance y. And remember, we also have this term 2ab covariance xy. But covariance is 0 if the variables are independent. If xy are independent, then covariance is 0. So that's why we just did a square variance x plus b square variance y, because the covariance term would be 0. Similarly, over here, sigma square x plus 5y minus 3 would be 1 square variance x plus 5 square variance y. And the covariance term would be 0 because x and y are independent. What shows on one die has nothing to do with what shows on the other die. That's why they're independent. And this would be variance of x was 91. What was it? 35 by 12. And 25 times 35 by 12. Okay, so what is this? 25 times 35, so 26 times, so if we factor out 35 by 12, we get 1 plus 25, that's 26 by 12, and 2 6 times, and 2 13 times. And 35 times 13 is 455. No, 350. And 35 times 3 is 105. So 455, yeah, 455 by 6.